This is Evan with EB3D Printing. In today's video, I'm going to go over how you can use a DSLR camera connected to the Raspberry Pi through a USB and use Klipper through either Mainsail or Fluid to capture images that you can later use to create time-lapse videos. But that's enough for me. Let's get into how to set this up. So before we dive into the applications that you're going to need to get this up and running on your Raspberry Pi with your DSLR camera, I just want to point out this isn't going to be a Klipper installation video or anything like that. This is just how to set up a DSLR camera through USB to capture photos. I'm going to assume you already have Klipper with Mainsail or Fluid installed. If you're using Klipper through Octoprint, I highly recommend just using Timelapse instead of going through all of this process. Like I said, this is mainly for people who choose to use Mainsail or Fluid for their Klipper installation. So to start off, the first thing I'm going to cover are a few applications that we're going to need in order to be able to complete this process. The first application, and the most important probably, is GPHOTO 2. Now before we dive into this and kind of go over what it is, you're going to have to see if your camera is compatible with GPHOTO 2. I'll provide a link to all of these pages in the description below. So starting off, we're going to go to this GPHOTO 2 document page. What this page does is it lists all of the compatible cameras that can use GPHOTO 2. It'll list that it has the library GPHOTO 2 camera support. It'll also list controllable aspects of that camera, so all of the things that you control on the camera through GPHOTO 2. It'll also include live view or webcam, so if you can do a live capture with your camera, it specifies that. It gives you the megapixels of the camera, and then it also, over here in the first column, is the camera name. So what I'm going to do is I'm going to scroll down through here. I have and use the Canon EOS M50 for my captures through making videos for YouTube and also making time lapses on the printer. As you can see right here, it is compatible. It has limited configurability through GPHOTO 2, but it also is supported by the library GPHOTO 2. It does allow for live view and webcam, and it's a 24 megapixel camera. So now that I know my camera is compatible with GPHOTO 2, I'll be able to install it and use it on the Raspberry Pi. So the next application, it's not really an application, it's a script you install that's kind of like a slice of life script. This allows for easier installation of Klipper, Octoprint, Mainsail, Fluid, all of that stuff onto the Raspberry Pi through a simple user-friendly interface. This is the Klipper installation and update helper. We're going to need this to install the shell command directory onto our Mainsail or Fluid installation. The shell command directory is needed to send capture signals to the camera so that it knows when to capture an image during the time-lapse capturing process. The next web page really is the guide of how to set all of this up. Essentially, this is a guide of how to set up DSLR snapshots on an open WRT box. So if you take a Creality box and convert it to a Klipper box, this is a guide you would follow to set it up for that box. Now, the way that we set it up on the Raspberry Pi is very similar. There's only a slight few changes. So I want to send a thank you out to Iona Haspra. Sorry, I probably butchered your name. And then also Will Batty. Those are the two main contributors on how I was able to set up this my DSLR camera through USB onto the Raspberry Pi. So like I said, this will be the bulk of the operation and the guide of how I go about setting this up through this demonstration video. So these are all the web pages and stuff that you'll need to check into. Like I said, I'll provide a link to all these in the description below. So let's dive into actually setting this up now. The first step in the process of setting up the DSLR camera is going to be installing GPHOTO 2 onto the Raspberry Pi. I'm going to be following the Timelapse method of installing GPHOTO 2. It's the alternative installation method. I will provide a link to this in the description below. So what we're going to have to do is we're going to have to SSH into the Raspberry Pi. So we have PuTTY up here. So we're just going to double click onto this and this will bring PuTTY up. Once PuTTY is up, we're going to log into the Raspberry Pi using our username and password. Once we're logged into the Raspberry Pi, it's very simple and straightforward from here. Just a bunch of copy and paste. So the first thing we're going to do is we're going to sudo apt install GPHOTO 2. Right click that into the PuTTY window and press enter. This will install GPHOTO 2. I will cut back when this is done. So now that GPHOTO 2 is done installing, if you have issues installing GPHOTO 2, it recommends installing the libgphoto2 command. I'm just going to install this anyways, just to, kind of go through the process, show you what happens. But once this is done installing, I'm going to actually cut back. So now that the libgphoto2 is done installing, the next up, we're going to have to configure the sudoers file. So we will copy this line right here of sudo vsudo, copy that. We will paste that into our PuTTY window and press enter. This will bring up the sudoers file. Basically, this is a copy of the sudoers file, but we will scroll down to here and we will copy these two lines and we will paste them at the bottom of the sudoers file. So we will use our arrow keys to scroll down. We will hit enter one more time and we will right click to paste these two lines in. Once we paste those two lines in, we're going to hit Control O and then file name, we hit enter, and then we will Control X to exit out of that file. Now this is another important note. When we go to configure the sudoers file, we actually need to know where the GPHOTO 2 is installed. So what we can do is we can list this command. We'll copy where is GPHOTO 2. We will right click, we will paste that in, and it'll show us exactly where GPHOTO 2 is located. So if your GPHOTO 2 installation is located anywhere different than this user bin GPHOTO 2, you're going to have to edit the line of root no password with your GPHOTO 2 installation. After we have GPHOTO 2 installed, we are going to go ahead and reboot the system. So we'll copy this and paste that in, sudo reboot, and it'll reboot our system. Once this reboots, I will cut back and we will continue on from there. At this point in the video, you're going to have your camera turned on and connected to the Raspberry Pi via USB. Next, you're also going to want to make sure that your camera is set up to be as manual as possible. What I mean by this is you'll want to have like manual shutter speed set. You'll want to have your manual f-stop set as well. Next, you'll also want to set your ISO for manual as well. And then I use a manual white balance as well. And I set that according to my lighting setup. After that, your camera is pretty much set up, ready to go. Now we'll dive into testing the camera through GPHOTO. So now that we have GPHOTO 2 installed, we have our camera connected to the Raspberry Pi via USB. We have our camera set up to be as manual as possible. We're going to log back into the Raspberry Pi and configure our camera through GPHOTO 2 to see if it's connected, to see if it's recognized, and see if it actually takes a snapshot. So let's log back into the Raspberry Pi. So now that we're logged back into the Raspberry Pi, I'm going to link this page down in the description below. This is one I forgot to mention, but this is the setup guide for Octolapse through Octoprint. We're going to need some of these commands, especially the GPHOTO 2 commands, to see if it recognizes our camera and to set up our snapshots. So the first thing we're going to do is we're going to see if our Raspberry Pi even recognizes our camera. So what we're going to do is highlight this GPHOTO 2 auto detect. We will copy that and we will paste that. We will copy that and we will paste that into our PuTTY terminal and press enter. This will show that our Raspberry Pi recognizes the Canon M50 and it's connected through this USB port. If your GPHOTO 2 does not recognize your camera, you're going to have to go back to the list to see if it's even supported. Outside of that, I can't really help much because there's so many different variations of cameras and there's so many different things that could be going wrong that you're really going to have to do some Google foo to see if you can figure out what's going on with your camera as far as not being able to be recognized. So now that we know our camera is recognized and GPHOTO 2 can detect our camera, we're going to run our first capture image script. What we're going to do is we're going to highlight this line right here. We're going to copy that. We will paste that into PuTTY and we will press enter. This will auto detect our camera and then try to run the capture image script. Now you may get an error warning saying that your camera failed to capture an image. It could possibly fail to capture the image, but it could also capture the image and it says a new file is located on the camera right here. So what you'll have to do is you'll have to go back out to your camera, wherever it's set up, and check to see if you actually have an image captured from the capture image script. Another thing we could try to do is we could capture the image and download that image. What this will do is it'll take a snapshot and then download that image to the Raspberry Pi. So what we'll do is we'll run this command. We'll highlight the capture image and download command. We will right click, paste that into PuTTY, and we will press enter. This will run the capture image and download command. And if it captures an image, so if this command is successful, what it will do is it will capture an image, it will save that file to the Raspberry Pi, and then it will also delete the file off of the camera. So what we can then do is we can hit the ls command to see if that image is captured onto the Raspberry Pi. The next thing we can do is we can actually open up WinSCP, we can log into our Raspberry Pi, and we can actually see if that image is located onto our Raspberry Pi. So we will copy this image, we will right click, minimize this, we will paste it to our desktop. Once the image is pasted to my desktop, I'm going to open it up to see if we actually successfully captured a snapshot. And as you can see, we have our printer bed in the frame and it is a successful snapshot. Now that we know we can successfully capture a snapshot, it's time to move on to the next part. This is where we're going to install the Klipper installation and update helper. I'm going to provide a link to this webpage in the description below. We're going to scroll down here to the installation script. We'll just copy this and we will right click to paste that into PuTTY and press enter. Since I already have it installed, an update prompt came up for me, so I will press yes to update. This will go through the update process and make sure everything's installed correctly. The next thing I'm going to do is I'm going to go back into the Klipper installation and update helper just by running this script right here. So we'll copy, right click, paste that in. This will bring up the Klipper installation and update helper. If you did not need to update, this is where you should be at right now. So what we are going to do is we're going to press 4. This will take us into advanced. What we're going to do is we're going to add the extension for shell commands. So we will press 9 and press enter. This will ask us, do you want to continue? We want to press yes. Do you want to overwrite it? I already have it installed, but so we'll press yes for this. Do you want to create a example shell command? No, you don't really need to do this. This just installs a shell command for hello world where it'll display hello world, but it's really not necessary because I will provide a link to my shell commands and macros for taking snapshots in the description below. So I'll press no for this. So once it's installed, we'll hit B to go back. We will hit Q to quit, and then we are going to reboot the Raspberry Pi. So sudo reboot, and that'll reboot the Raspberry Pi. Next up, we're going to log into the Mainsail interface and get started with the shell commands and scripts for that. Now that we know that our camera can take a snapshot through GPHOTO. It's time to log into our Raspberry Pi through Mainsail and set up Mainsail and the required configuration files and macros needed to make a time lapse. Now that we're in Mainsail on our printer that we're going to set up the time lapse on, we're going to go down to the configuration files. You should have a file, shell_command config file. If you do not have a shell command config file set up, you can easily just create a file, type in the name of shell_command.cfg and create a new file that way. Since I already have mine set up and plugged in, I'm not going to create a new file. But like I said, if you don't have one, just create a new file and we will go from there. So in this shell command file, we're going to create two commands. The first shell command we're going to create is a set config command. What this set config command does is it sets the capture target of your image to the SD card on the camera itself. So what we can do is to figure out what your capture target should be is we're going to log into PuTTY and use a GPHOTO command to figure out the capture target of our image. So now we're logged into PuTTY and connected to the Raspberry Pi through SSH. We're going to use this GPHOTO2 get config capture target. So we'll right click and copy this, and this is from the DSLR snapshots webpage, but we'll right click and paste that into PuTTY. And what this will do is it'll list the choices we have for our capture targets. Choice 0 is the internal RAM of the camera, which we don't want to use, and choice 1 is the memory card. So now that we know what our choice is for our capture target, we'll go back over here to the shell command configuration file, and we will set our capture target to 1 for the memory card. So the next shell command is our trigger snapshot command. What this will do is this will trigger the snapshot command on the camera to take an image at each layer for our time lapse. So like I said, I will have this file linked in the description below, so you can just basically copy and paste what I have. What this will do is it'll auto detect the camera and then send the capture trigger to the camera to take a snapshot. It'll time out for about 10 milliseconds. This will allow enough time for the camera to take an image before the command ends and it returns to printing. So before we get into setting up the macros for taking time lapse, what we're going to set up next is firmware retraction in the printer config file. We're going to add a firmware retraction section to our printer config file. You can find this information on the Klipper documents page. Basically what it does is it allows for you to set the retraction length, your retract speed, your unretract extra length. So this is like extra extruded amount at the end of the retraction. You really don't need this. This will just add extra stringing to the filament that's already oozing out of the nozzle while the nozzle is parked. Then it also allows you to set the unretract speed. Now this is going to be printer and filament dependent, but I'll provide a link to this section in the description below so you can copy and paste this into your printer config and set it up to your printer's specific settings. It'll also take some time to figure out, how much you want to retract to prevent enough oozing so that way you don't have a bunch of stringing plastered to your print after the nozzle is parked. So once we have this set up and into our printer config file, we're going to save and restart Klipper. So now it's time to move on to setting up the macros for the snapshots for time lapse. I'll provide a link to this file in the description below as well. That way you can copy the time lapse macros and paste them into your macro file. The first macro we're going to set up is the capture target. Basically, this sets the capture target of the time lapse photos to your camera's memory card. The next macro is the take snapshot macro. This is the macro that is actually going to take photos for the time lapse. What this will do is it'll set a delay of how long the nozzle is going to be parked while it's taking a snapshot. It'll also set up the X and Y position for the snapshot of where to park the nozzle, and then it'll return the nozzle print head to wherever it was when it was before it took the snapshot. It'll also go through and do the firmware retraction. So you can have a separate retraction for your snapshot than you do for your printing. If you need to add a little more distance to your snapshot when you take a photo, that way you don't have any oozing during the photo taking before it returns to printing. That way you prevent all the blobs and stuff going on to the print during the snapshot. So we have the G10, which is the retract command. And then we have G90, which is absolute positioning. And then it moves the print head to the park location. It pauses for our delay. And then what it does is it runs the trigger snapshot command and then returns to the original position and then unretracts the filament and returns to printing. The last macro I have is kind of just a test macro. What this does is it just basically, I just press the macro from the macro section on Mainsail. And what this does is this allows me to test the trigger of the camera just to see if it's functioning properly before I go into printing a print and taking a time-lapse photos. So after we have these in our macros config file, what we're going to do is just going to save and restart. The one thing I want to point out is after we get the shell command file made up and the macros set up, if you run into the error of, say, we'll run a test macro real quick of GPHOTO set target. If we get an error that says unknown command, run shell command, what you'll actually have to do is you'll have to go back into your printer config, open up your printer config file, and make sure that you include the shell command configuration file. Now, it doesn't have to be named shell command. You can name it like timelapse config or whatever you want to name it. I just named it shell command as a reference to what we're actually doing, and that is calling shell commands. So once you have include shell command in your configuration file, we'll come over here, we'll hit save and restart. This will restart Klipper. Once Klipper is restarted, now I have to do it a special way since I have two instances of Klipper running on this Pi. Once Klipper is back up and running, we'll come over here and we will go to our printer. We'll come down here to macro and we will run our test macro again. And as you can see, it clearly activates the macro. So like I said, if you run into the error of unknown shell, run shell command, make sure you include the shell command file in your printer config. All right, so now that we have our macros set up, it's time to set up our slicers to use those macros. I'm going to be using Super Slicer as the first demo of how to set this up. And what we're going to do is we're going to go into our printer settings to custom G code. We're going to scroll down to our layer change sections. Now, I don't think it really matters which section you put the macro in. It doesn't really affect the quality of the time lapse, but I prefer to use it in the after layer change G code. That way it takes a snapshot of the last layer printed of the part that we're making a time lapse of. So in the after layer change G code section, we're going to type in the name of our take snapshot command, which happens to be take snapshot. So we're going to type in take _ snap shot. And then once we have that in, we're just going to save our printer config and we're going to hit OK here. Now that will place the take snapshot command after every layer change in the sliced file. So next up, we're going to move over to Cura. We're going to go to select our printer that we're going to put the snapshot command into. We're going to go to extensions, post-processing, modified G code. We're going to add a script. And in the add a script section, we're going to insert at layer change. Again, you can select before or after, but like I said, we're going to select after for this. We'll type in our take snap shot macro command, and we will close that. And this will insert the take snapshot command after every layer change. So the last slicer I'm going to cover is Idea Maker. We're going to go over to the G code tab. We're going to go to our layer change G code, and we will just type in our take snapshot command here. And unfortunately, this doesn't allow us to pick before or after the layer change. So this will just put in the take snapshot command at the layer change section. So we'll just click OK. That'll save that. And now we're done setting up the slicers. Next, we'll actually go into slicing a file and running the time lapse, and I'll give you a demo of how it works making a time lapse with Klipper running Mainsail. So now that our print is finished up and we have all the images saved to the SD card on our DSLR camera, what we're going to do then is we're going to take those images and transfer them from the SD card over to the computer. So we'll just shift, highlight all these, and drag them over to a selected folder that we have for this time-lapse file that we're going to create. Unfortunately, with this method, you cannot auto-compile the time-lapse on the Raspberry Pi at this time. This is due to Mainsail's current time-lapse setup not supporting shell command inputs at this time. Maybe later on down the road, they will implement it to where we can run shell commands through their native UI time-lapse config. But right now, this is how I have to do it using a DSLR connected via USB. I want to preface this by saying this isn't going to be an all-encompassing guide to SHOTCUT. This is just going to be a quick and dirty how I go through setting up time lapses to where I post on Instagram or YouTube or anything like that. If you want more in-depth details of like special effects you can add to the time lapse, like zooming in, zooming out, reverse, forward, 2x speed, stuff like that, I'll provide a link in the description to another YouTube channel that I follow for quick tips on how to do things like that in SHOTCUT. But like I said, this is just going to be a quick and dirty how I go about setting up time lapses. So let's dive right into this. So the first thing you'll be presented with is this new project screen. You can set up the projects folder. This is where you want the SHOTCUT projects file saved. You can set up the project name, and then you can also set up your video mode. Now we're going to name this simple cube test because that's what it is. It's just a cube test using Mainsail with a USB connected DSLR. For video mode, you're going to want to set this to whatever aspect ratio the images are that you took the time lapse in. Now for me, I did a 4:3 aspect ratio, and there really isn't any specific 4:3 aspect ratio selections available. So what I do is I come down here to custom and I select add. Now I will name this 4:3 time lapse, and then I will change this to 1920 by 1440. This will give me enough aspect ratio that I can put it onto Instagram and have enough definition to the images to where you'll be able to make out what it is. So we'll change the aspect ratio to 4:3, and we will keep the frames at 25 frames per second. Now we can shorten this and we can speed it up using fast forward, slow down techniques later on. Like I said, I won't cover those in this video. So everything else looks good. We will select OK, and we will select Start. Now, if you're not on this tab, you'll want to make your way over to this and select the Playlist tab down here in the lower left-hand corner. Now, after we select that, what we're going to want to do is we're going to want to bring up our folder that contains all of the images for our time-lapse. So now that our folder is up, what you're going to want to do is you're going to want to select the very first image of the time-lapse and drag that over to the playlist file or playlist section of SHOTCUT. Once this is in the playlist section of SHOTCUT, you're going to want to go over to the Properties tab. Now that we are over at the Properties tab, you can select a few things here and change what you would like. Now the duration is how long each file or each image in this instance is displayed. Typically is set to 4 seconds for the duration. I changed this down to 2 seconds, and we can drag and adjust that later on. Now, the very important selection we're going to make next to turn this into a time lapse is image sequence. This will take all of the images in that folder where our time lapse is saved and put them into a sequence. All right, so now that our images are into a sequence, you could see it progress through the files on the display. So right now our time lapse is only 4 seconds. Now we can increase this by repeating each frame a select number of times. Currently, each image will be repeated 1 time. So if we increase this to 2, each image will be repeated 2 times. This will slow down our time lapse so you can get a better idea of what is going on. So now that our properties are set up for the time lapse, what we're going to do is we're going to just drag this image down to our timeline. And this will put our time lapse into our timeline. So now that our time lapse is into our timeline, we're going to bring up the folder again that has our images in it of the time lapse. Once our folder is up, what I do is I select the first image of the time lapse and drag that over, and I select the last image of the time lapse and I drag that over. Once these images are in our playlist, we can adjust the duration of each image through the slider on the timeline. So now that I have moved myself out of the way so you can get a better idea of what's going on here, what I'm going to do is I'm going to take our time lapse that's in our timelines and just drag it out of the way a little bit. This will give us space before the timeline to add our first image. And what I do here is I take the first image and I just drag that down to the timeline. Now this image current duration is 4 seconds, and you can use your slider to adjust that down to whatever duration you want to use. I typically adjust it down to 1 second. So there's 1 second left, and then I drag over the time lapse again. And then we just hit Shift Home, and that'll take us to the beginning of the timeline. Now to zoom in here, this will give us a better idea of what's going on. After I drag the first image of the time lapse onto the timeline, I then drag the time lapse over to where it is half a second. It's 15 to where it's a half a second intro of the first image, and then it will transition into the timeline. I then do the same thing with the last image of the time lapse. So I take image number 3 here, drag it over to the timeline, click on the right side edge. I drag this down to 1 second. And then I click the file and I slide that over half a second. So now we see the last image for a half a second at the end of the time lapse. Now that our time lapse is done and it's set up typically how I have my time lapse is set up, we are going to export this. Now this isn't, the definitive how you set up time lapses. You can adjust these things to your liking. Like you can have no transitions between the first image, last image. You cannot even put them in. This is just what I like to do so you can get a capture of what's going on before the time lapse starts and get an idea of how the file looks or how the print looks after the time lapse is done. So what we do to export this is we go over to the export tab. Now all of this should be set up to what your project is set up currently as. So it's 1920 by 1440, 4:3 aspect ratio, 25 frames per second. The only thing I change here is the interpolation. I change that down to Lanczos for best, so that way we get the best quality export of the file when we go to export this. As far as format, I just use this MP4. Now that we have, our settings set up and configured the way we want to, all we do is we go ahead and we click export file. This will bring up a folder of where we want to save our file. I'm just going to save it to our default project file. So we'll click save. Once you click save, SHOTCUT will then begin exporting the file to wherever you have it saved. Now that SHOTCUT has successfully exported the time-lapse file, we'll go ahead and view it and see how it looks. Well, that concludes this video on how to set up a DSLR camera connected to the Raspberry Pi via USB and through Mainsail using shell commands and macros. You're able to capture time-lapse images. Now I hope this is just a temporary workaround, and in future releases of Mainsail, they're able to implement shell commands and utilize GPHOTO 2 into their native time-lapse UI. But like I said, for right now, this is just a workaround we have to do in order to use DSLR cameras connected via USB. If you have any questions or comments, please feel free to leave them in the comments section below. I try to answer any and all questions I can, and if not, I try to point you in the right direction for the answer. If you like this content and would like to see more from me, well, you know what to do. If you would like to support this channel and help me grow, I have links to do so in the description below. But as always, that's enough for me, and I'll see you in the next one.